Chapter 2.3, the sine law. The sine law is for oblique triangles, so non-right triangles. If we're not working with a right triangle, this means we cannot use Pythagorean theorem, and we cannot use the primary trig functions or SOHCAHTOA. A little review of sides and angles in a triangle. The side across from an angle has the same name as that angle, but lowercase. So capital A angle is across from side lowercase a. Capital B for the angle is across from the side called lowercase b. And capital C angle is across from side lowercase c. The sine law states that the sine of angle A over side A is equal to the sine of angle B over side B and is equal to the sine of angle C over side C. Or we can flip that upside down, and then we have side A over sine of angle A is equal to side B over sine of angle B, which is also equal to side C over sine of angle C. So the ratio of sine of an angle over the side across from it is equal for each of the side angle pairs in a triangle. Example, find A, side A. To check if you can use the sine law on a triangle, ask yourself these questions. Number 1, is this a right angle triangle? No. If it is a right triangle, then we shouldn't need to use the sine law because we can use Pythagorean theorem or the trig ratios. Number 2, do we have an angle in the length of an opposite side? Yes, we have 47 degrees and the side across from it, which is 18. Yes. We have one full pair. And then 3, do we know one other piece of information? Yes, we do. We have the angle that's across from side A, so that would be angle A. We have half of a second pair. We have angle A. Then we're going to write the sine law. We only need 2 ratios. Sine A over A equals sine B over B. We could also put it the other way around, have little a over sine capital A. And then we fill in our values. So sine of capital A would be sine 42 degrees over A equals sine B, that would be our other angle, sine 47 degrees over side B, which is 18. And then to solve, we cross, multiply, and divide. Multiply your diagonal numbers, divide by whatever your third number is. Let's bring up our calculator. Check to make sure we're in degree mode. Sine 90 should equal 1. It does, so we're in degree mode. I want 18 times sine 42. Get out of the sine 42 and then divide by sine 47. And we get 16.4685. Let's round to the nearest tenth, is typically where we round to for side lengths, and the nearest whole number for angles, so 16.5 in this case. Next example, we want to look for our angle side pair. And then we should have another half pair. And we're trying to find the other half of that pair. We set up our sine law. You can have the angles on top or the sides on top. It doesn't matter. Maybe I'll do the sides on top since I had the angles on top last time. So I have A over sine capital A equals B over sine capital B. Then I plug in my values. X is the side length I'm trying to find over sine of the angle across from X, which is 42 degrees. The other side angle pair, the side length is 25.3 over sine of the angle, which is 76 degrees. Then we're going to cross multiply and divide. Multiply diagonal numbers first, and then divide by whatever you have left. So I'm doing 25.3 times sine 42, move out of my brackets, and then divided by sine 76. And that gives us 17.4472. And rounding to the nearest tenth, we get 17.4. The next one, looking for my complete pair, I have the 15-degree angle and the side across from it is 19.7. I'm trying to find X. If I look across from X, I don't have that angle, but I do know the other two angles, so I can figure out that angle. The angles in a triangle always add to 180. So I start with 180 degrees and I subtract the two angles that I know, minus 50 and minus 38, which gives us 92, 180 minus 50 minus 38, 92 degrees. So this angle is 92 degrees. Then I have half of the pair that includes side X. Write my sine law. I'll do the angles on top this time. Sine A over A equals sine B over B. Then I plug in my values. I'm trying to find X, which is across from angle 92. So sine 92 over X equals, the full angle pair has 50 degrees for the angle, so sine of 50 degrees. And the side length across from that is 19.7. Cross multiply and divide. Multiply diagonal numbers first, then divide by whatever's left. 19.7 times sine 92. Move out of the brackets, divided by sine 50 equals 25.7008. Round to the nearest tenth, we get 25.7. Next one, look for the full pair, which is here. 42 degrees is across from side length 22. Then look for the half pair, which is here. We have the side length of 18. We're trying to find angle theta. So this is the first time we're trying to find an angle. Again, you can have the sides on top in the sine law or on bottom, doesn't matter. Write out your sine law. Sine A over little a equals sine B over little b. Plug in your values. We're trying to find theta, so sine theta over the side across from theta is 18 equals, our other angle is 42, sine 42 degrees over the side across from that is 22. Again, cross multiply and divide. Multiply diagonal numbers first, then divide by your third number. This one is sine 42, move out of the brackets, times 18 divided by 22 gives us sine theta equals 0.5474, etc. So this is not the angle. We have to find the angle still. We have sine of the angle is 0.5474. So to find the angle, we do the sine inverse of that value, 0.5474, etc. In my calculator, I go second sine to get sine inverse, and then I can push second and then the negative button to tell the calculator to put the last answer in there, and then enter to calculate, and we get theta equals 33.1936. So rounding to the nearest whole number for angles, theta equals 33 degrees. Last example. In triangle ABC, angle A is 64 degrees and side A is 25.3 centimeters. Side B is 16.5 centimeters. What is angle C to the nearest degree? So we have to draw our triangle in this case. It doesn't really matter if your triangle's drawn accurately. So if your angles look like they should, you really just need to draw a triangle. And then label it A, B, C in this case. So then side A is across from angle A, which would be here, and that is 25.3 centimeters. We know that angle A is 64 degrees. Side B is across from angle B, which would be here at 16.5 centimeters. And we're trying to find angle C, so we'll label that theta. We have a complete pair here with angle A, side A, and then we need half a pair. I'm trying to find angle C, so I would need the side across from C, but I don't have that information. The only other thing I do have is side B. So what can I find if I have side B? I can find the other half of that pair, which would be angle B. Once I know angle B, can I find angle C? Yes, because the three angles in any triangle add to 180. So once we know two of them, we can find the third. So let's start by finding angle B. Write your sine law, angles on top or sides on top, whichever you prefer. Maybe this time I'll put sides on top, so A over sine A equals B over sine B. Then plug in our values. And it doesn't actually matter. The fact that this triangle happens to be labeled ABC and the A and B in our sine law, they don't have to match up. It's just whatever pair, just that a pair needs to go together. I usually put my unknown value in my first fraction, but it doesn't matter. So you can match these up so that your first fraction is actually A and A from this triangle, or however you want to write it, as long as the B's are together in one ratio and the A's are together in another ratio. I'm going to put side B first, 16.5 over sine of angle B equals side A, 25.3 over sine of angle A, which is 64 degrees. We're going to cross multiply and divide. Multiply diagonal numbers, divide by what's left. Sine 64, move out of my brackets, times 16.5 divided by 25.3 gives me 0.5861. Sine B equals 0.5861. Then to find angle B, I do the sine inverse of that. B equals sine inverse of 0.5861. In my calculator, I do second sine, and then second negative button to get answer in there, and then enter, and we get B equals 35.8856 ... So B rounded to the nearest whole number would be 36 degrees. Then we want to find angle C. We know that the three angles in the triangle add up to 180. Angle C equals 180 degrees minus the angle we were given, 64 degrees, minus the angle we just calculated, 36 degrees. Angle C equals 180 minus 64 minus 36 gives us 80 degrees. That brings us to the end of Chapter 2, Lesson 3.